All right, let me just adjust this camera real quick. Um, Welcome everybody back to the weekly Friday open studio design session. Like I said before, in the streams in the past, the idea behind this live stream is that I'm working on a project of mine, and you can also work on one of your projects in the meantime. And so it's kind of like a virtual open studio, so to speak, and kind of just have like a creative atmosphere here on a Friday afternoon. And you can work on your projects, and I'll be working on my projects and just kind of walking you through my process. And this is like, it's easier to create than official videos, so that's a good thing, and it also forces me to do something every week in terms of this hobby. So today, I guess we're going to continue our build of the F-16 that we started last time. Or we didn't start last time, we started several streams ago, but we made some progress last time, and let's just go over what we did. So if I'm remembering correctly, last time we made this tail assembly mechanism here. So this is the part of the mechanism that's going to be linked up to this slat system eventually, but this is what we made last week. This is the same design kind of configuration as the Astra. So if you know that, it's a project of mine that I did last year, and essentially what it is a mechanism, a way to actuate control surface via a center friction lock mechanism. So it's a little bit complex. I realize that it's not very straightforward, but you can see we made some progress here last time by winding this blue mechanism link around this I guess output shaft, which is the orange bit, and the orange bit is the part that's going to be attached to the actual tail surface. So that's kind of the plan. And we made some progress here. I think the next step was to continue assembling the mechanism, because really that's kind of the heart of this design. Like the whole point of this project is to get an F-16, but not only that, we want it to have some moving parts so that it's I think it captures the heart and soul a little bit better for the model. You'll notice that here we have the center, I guess, linear bearing. It's kind of just, it's a straw. Essentially is what it is. It's made out of straw. We're going to take two of these thin diameter straws. You see there's a size difference here, and we're going to pinch them together and create a double layered shaft, and just kind of put it inside here. And once we do that, we can start to like put in a neutral point here, a pin going through the neutral point here, and there's a little slot in the front here as well, so we can put a pin here and work off of that. Essentially the pins are what's going to be attached, or what's going to interact with these outputs. So we can get started by doing that. So that's one of the steps that we need to do, and that's pretty simple. So I think we might start there. But we also need to assemble these parts. Nice thing is they're already made, so all we have to do now is kind of just close it off and make it one piece. Um, I know, like, it's a lot of work actually to get it to be at a tight tolerance. Um, of course, I can rush, but then the end product isn't going to be that great. So, for today, we're just going to take it slow, see how far we get, um, and yeah, let's just get started here. So I'm going to move some of this stuff to the side so we have more room to work with. So we have the guts of the mechanism already made, which is good. And we just need to kind of link everything together. So I'm gonna get a straw real quick. Rather get 2 straws. So we're gonna start off by making just blowing off some of the dust on this thing. I'm gonna make the center shaft here. Now that I'm looking at it, it's a little bit short, to be honest. It's not a lot of wiggle room here. The black straws are a little short, and you can't just like tape them end to end, even if it's double layered. It's just not a good joint. But let me see what I can do here. We need the actuation rod. We need a little bit of handle room, right? We don't want it to be too tight, I guess, not enough handle space to grab onto. That's not good, because then once you push it in, you can't pull it back out, so you don't want that. That's like the only downside about this new mechanism, is that you can't really determine how far to go, and if you push all the way in, you're kind of screwed, because then how are you going to get it out, because the nose is going to be sealed off. Let me just grab my tape real quick. So this is kind of how I do the double straw shaft. You just kind of take a piece of tape, right, kind of pinch it together, make sure it's relatively close together. Just kind of secure both of them first, right? Make sure the adhesive is sticking to the straw. Kind of just scratch it a little bit so that remove all those bubbles, because that's the area underneath that's not being taped. So, and then you just kind of wrap it around. Right, same idea. Just kind of press away the bubbles as you go. So that's all right. That's not great. Not ideal. So I shifted my grip a little bit, and so it's not perfect. Let me just try that again. It doesn't have to be perfect, but I'd like it to be as good as it can be. Just scratch that. Got most of the bubbles out. Right. And you'll see that if you do it well, and the tape becomes parallel with the end here, and it doesn't want to wrap in a spiral around this entire thing. So that's how you know you've done good, I guess. So I'm gonna tape the other end here, and this is kind of tricky because you don't want it to twist, right? It's hard to make sure that things are aligned, but you want to try and make sure they're good there. Right, so this is okay. You'll see here I wasn't too precise, and there's a little bit of offset. The tape kind of spiraled down a little bit, but I think this is acceptable, so I'm just gonna leave it as is. So this is going to go somewhere here. Not sure how much handle I should leave. Probably at least an inch. If I go from neutral to up, that's going to be okay. But pulling down, that's gonna be the tough one. Speaking of which, it's gonna be kind of hard to right, so this is reversed notation, because when your slats are down, your tail is also down, so they're synchronized actually, so they're both pointing down here, but I labeled it differently, if you remember, in past builds. So this is going to be an issue. I'm just worrying about like how we're going to synchronize this, because we can move the tail, I guess, pitch up to pitch the plane down, right? That's why it's labeled D here. But then how we don't have enough room here, so that's going to be a interesting thing. We might have to extend this slot a little bit. I'm just noticing that now, but we'll cross that bridge when we get there, I guess. I'm just gonna tape the middle a little bit. So just one band of tape around the middle point here. Looks good. So yeah, there's really no like kind of established method for this. You just kind of do an eyeball to the best of your ability. I mean, you could measure it out and then label it, but for taping, as long as it, doesn't separate at the midpoint here, because it wants to tend to separate here. As long as it doesn't do that, we're all set. So now we have our main shaft. This is the part that's going to actually move the mechanism, right? Because you're moving this back and forth. So this is important that you get this right if you do end up copying this. So just gonna check the chat really quick. Vogel OG, the model looks amazing. Thanks, man. I appreciate that compliment. It's a work in progress, right? I wish I could get it done faster, but I also want to do a good job. That's why it's taken a while. Alright, so this is going to be an interesting detail here. You want the, kind of like a seam. I'm just going to call it a seam. You want the seam to be perpendicular to the slot holes. And there's a very clear functional purpose for that. You can't have the seam be parallel, like, I guess, collinear with this slot, because this material is literally what's moving the pin. So if your pin goes through the slot, right, and it goes through the middle of this, and you're not gonna be able to actually react any force. So it's just gonna slip when you move, right? You don't want that. So for this mechanism, you want to have, or for all of these, I guess, actuation mechanisms, you want to have the slot, like the window to the straw, be at a surface, not a seam, I guess is my point. But you really want to get it at a 90-degree angle, just to really make sure everything is all set there. This is causing some weird warping issues slightly, because the straw wants to expand. So essentially what it's doing inside this orange straw is it's pushing out a little bit. And because we cut a slot here, there's all types of, deformations, like, you can see a little bit of wobble maybe. it's not uniform anymore. So it's not perfect, but I have to just make do. Just kind of slide it in. And really, you want to align it early on because it's harder to twist while it's deep inside. So I'm just pinching this a little bit, sliding it in bit by bit. You don't want to push from the back too hard because sometimes it buckles, and when it buckles, it creases and weakens the plastic. So you don't want to do that. So you want to hold it close so that it doesn't buckle. Yeah, this is tight because this the tape adds a little bit of thickness and it kind of acts as a stopper, but we want it to go in. Actually, this is good for neutral, but we would like it to fit inside the tube, just so that we're able to go to from neutral to up. I mean, I guess we could retract it back like the same amount and then have a bigger handle in the back. But then it's just gonna look a little bit weird, if you have such a long, because the nozzle on the F-16, it already ends like right about here, so I guess it's not a big deal. It just looks a little weird if you have too much of a thing in the back hanging off of your airplane. So let me see. Are we okay with this? Because if not, then we're gonna have to really fit it in, which is gonna be tough. You just kind of have to apply a lot of force to get it to go in, I guess. This isn't perfect because the tape is eventually going to wear and it's gonna start to come off. Well, I guess it works. It's just not. It's a really tight fit right now. Let me see. Should be good. One of my concerns when I initially designed this mechanism was that, you have your pin going through these two straws. And, the problem is when you have plastic like this and you have a very small hole and you apply a force right onto the pin, you imagine the pin like just sliding through the plastic and just kind of ripping its way through, right? It's just kind of a material property issue. And so initially I thought about mitigating that problem by applying a piece of tape, right? Kind of like this, but in the middle. And then you put your pin through this. That's, the idea behind that is to give it a little bit more support on this plastic to prevent the pin to slide through and rip through the plastic. But turns out you don't really need that, and it's actually sufficient because we're not dealing with like huge amounts of stress. And it's very interesting because these, the pins are going to be made out of paperclip. Let me just grab some right here. For the pins, I usually go with like a slightly different type of paperclip. It's silver, right? It's very low friction, so because there's no rubber layer around it. This type of paperclip right here, you can see there's like a skin around it that's giving it the blue color. So, and that adds a little bit of friction to the mechanism. So just important to keep that in mind. But for the pin, I use this type of paperclip. It's just pure stainless steel. And the interesting thing is that when you put this through and you try to pull it, it doesn't rip as easy as you think it would. So that's kind of the learning that I came across through my testing here. Um, and the reason for that is, your pin is not like, I guess, a very sharp thing, right? It's rounded, right? When you can't really cut yourself with this wire. I mean, if you tried hard enough, you would be able to. But this thing is point is this thing is blunt, right? Is not very sharp, and so when you have a circular hole and you're applying like a force to one side, it actually distributes it. It's not a very tiny point. There's a region of contact when you try and move it, right? Kind of like that. So, so that's interesting. That simplified the mechanism, right? Because I was thinking if we had to tape the whole thing on the inside, that's gonna add a lot of friction. It's just a lot, right? Because right now we only have like 3 bands of tape, and it's already really tight. But if we tape the whole thing, this diameter is gonna be bigger, and so it's gonna apply more pressure, and we're gonna get more friction in the overall mechanism, which is not ideal because we want it to be able to move, right? We don't want it to be stuck in one position like really tightly. That would not be very useful. Right now I'm just gonna try and reapply some of this ink here. So it's kind of wearing off a little bit, but fixing that. So this is kind of the neutral position, and no, that's good. Just wanted to test this. If I push this in, will I be able to pull it back with this amount of handle? Right. This amount, and then you can pull it back out. So it's nice because this is like a 3/4 of an inch, right? Because that's the width of this tape that I'm using, and half of that is almost exactly how much movement we need. So where the tape ends, that's kind of the neutral position right now. I'm defining it like that. You can pull it out, which I doubt we will do very often. We're probably not going to do that a lot. So actually this slot is a little bit oversized because we likely won't make our plane pitch down. We usually want it to pitch up to pull out of a flight. When you launch it, you don't want it to nosedive into the ground, so you pitch up, right? So you just move this forward, tail surface moves, and then you pitch your plane up. So we probably won't be using this, and now that I think about it, this is probably unnecessary, this back part here. But you want to be able to have that range of motion just in case. Now the question is, how are we going to link the back part here with the with the slat deployment mechanism? Because both are synchronized to go point down when you slide the rod forward, right? So when you slide it forward, imagine the pin, right, grabbing this blue part, going forward, you're gonna have this orange part rotate down, which is gonna pitch your plane up. So I'm not too clear on that, to be honest. I didn't plan this through. But it's kind of what it looks like right now. All right, we're gonna wrap this blue around a pin through the neutral point here. So whenever we create this neutral point, like put a pin through, we're gonna do the same here at this location. I think this is a good position for the handle. This is enough room to actuate. And, just kind of a word of caution, we're just not gonna push it all the way in because that would not be good. And I don't think it will allow that either, because this mechanism, right, if you have a pin at neutral, when you push forward, you're gonna face some resistance when the pin reaches the end of the slot here. And that's right about here, right? Push in, so it's gonna leave this amount of room on the handle before the pin, hits something. So I think we should be all set there, just for, I guess, safety and in design. Like, it's not like for safety, but it's like just, I guess, what's it called? I guess just I don't know. I lost the train of thought there. It's just good design, right? You prevent user from creating a problem, an error that they can't solve easily, right? Just thorough design like that. Okay, so we have the handle in place. I'm gonna have to unravel this a little bit. Let me just check real quick how I did it on my Astra prototype here. It's underneath my desk, so I'm just grabbing it real quick. It's in a shoebox. Alright, so this is sorry about that. This is the Astra, right? This is a work in progress. I need to work on this. I have left this in the shoebox for way too long, but you can see that this is kind of what the mechanism ends up looking like, right? This actuation right here. This is what the tail section of this F-16 is going to look like. So when we push forward, it's actually going to pitch the plane up, because this surface here on this plane is an elevator. It's not a canard. So it's going to push the tail down, which is going to point the nose up. So this is kind of the work in progress here. This is kind of this is the slat mechanism that I designed initially for the M1, right? This is the YX10 M1. This is kind of what it looks like when it's done. So we're trying to get this in our build of the F-16. Right, you can see the leading edge slat points down. It's really sharp, right? Also the wing and just overall profile is very thin. It's super thin, and that's by design. We're switching the spar to popsicle sticks, so that'll be interesting. You'll see how it's all integrated. It's really clever, in my opinion. It's a very tight and clean integration. Like, this spar serves two purposes. One is to provide, like, you can hold it by the wingtip and this plane won't bend its wings. So it's very strong, and it also serves as the rotational bearing here for the slat surface. So it's really cool. I really like it. It's very, like, you wouldn't think about it, but it's just like, wow, okay, you really just did that to make the mechanism possible. So I can demonstrate this a little bit here, the actuation of the slat. So you push forward to retract, right? And then you pull back to deploy. Yeah, it's very slight movement, so you won't be able to see it too well. But when you pull back, you deploy, right? And you push forward, you retract. It's very slight movement. So in the case of the F-16, the movement is actually reversed. And what I mean by that is when you have your slat retracted in the neutral position, it's literally just retracted in neutral, right? When you push forward, it's going to push this rod down and it's going to deploy it. So these two are synchronized. The reason why this is different is that it's on the underside. So really, if you think about it, this is kind of the way that it's supposed to be. If you think, like, if you imagine this surface right now not being deployed, if you imagine it being horizontal, and the direction that it's rotating when you push forward, right, it's down. It's just offset by a certain amount. And so when we put it on the same side, like on the top side of this F-16, we can actually synchronize both of it. And that's just a function of the configuration, right? Your tail is behind your wing. That's why you're able to synchronize both of these mechanisms together. Because in a canard configuration, you actually have to pull back to deploy this if it's on the bottom, right? If it's on the top, then it's synchronized with the canard here, which wouldn't work if you think about it, because you're pitching down with this kind of a canard angle, and if you're pitching down, you wouldn't need this to really help you turn, I guess. You really want this when you're pitching up, because that's when you have a high angle of attack and you need the air to flow over your wings, so you lower your slats to get that extra airflow without separating it. So that's kind of the design reasoning behind that. It's just a little different on the F-16. That's kind of the whole point. Just put this to the side. So that was a tangent. We haven't actually done much. Let me just unravel this paper clip. I'm just trying to make the pin real quick. For the pin, I'm wondering how long the kind of arms have to be. I'm gonna make it really short, but then this might pop off, so we don't want that. If it's longer, we can wrap tape around it and it can slide back and forth, right? It's just a little bit more reinforced. And that tape is not standard procedure. I just thought about it now, because the way it is on the M1 prototype, we have the silver piece wrapping around the front end here, but we're not able to do that in this new mechanism because this, obviously you don't have an end to wrap around here. So I'm just thinking, like, instead of wrapping it around the straw, you just kind of end it right here and tape this portion right here, right? That way it doesn't shift around up and down too much, but it can shift forward and back through the tape. It's just kind of an idea that I had. So I'm gonna go ahead and do that. But first, before we do that, we need to unwrap this paper clip. And again, if you're trying to do this and you have like a roll of wire just lying around, please do use that. It saves time, but it has to be thin, right? The wire has to be thin as this paper clip. So I'm just gonna move the camera down a little bit and we'll be able to see how to do this. It's the same idea as the orange and blue paper clips. It's just a different one right here. This is it's a smaller paper clip, so it's a little tougher to bend into shape. Okay, looks good. All right, and then this little tiny bit here, we probably won't need this, but it's just good to have it available just in case. All right, this is kind of tough. You just grab a pair of pliers real quick. So these are needle nose pliers, right? Help you get a grip. And you want to make sure you don't like cut yourself or damage your nails or anything. But yeah, this is pretty tough. It's very slippery too, because there's no coating on this type of paper clip, right? It's just pure stainless steel. So I'm just gonna hold this, bend it straight. Alright, it doesn't have to be perfect. And really, we don't need all that much, to be honest. We could cut this in half and use the entire paperclip for both sections of the mechanism. Let me just straighten up this portion right here. Right. You could do the same thing with a pair of pliers, but I find it easier to do it with a ruler, because then you can align it with the edge and make adjustments. This isn't perfect, but it doesn't have to be, because literally the only section that is going to rely on this is the part that's really close to the straw in the first place. So we could measure exactly what we want and make the pin ready to go. So it's approximately this much on each side. Right, just measure this. Alright, so we have a centimeter here, approximately 0.8, I think. No, it's 0.7. Alright, 0.7 on both sides, but we want 0.8 because we want a little bit of gap so that this has something to wrap around. So 1.8, so 2.8 centimeters on this. Just call it 3. We only really need 3 centimeters, but we don't want to cut it and then try and bend it. That's going to make our lives a lot harder. I will, however, try to mark the locations that we want. It's going to be slightly difficult because there's no coding on this thing. I think it's 0.8 for the middle section here, and then 1 centimeter from the center to the other side. Right. So I think that should be enough, because for the most part we're just going to be going forward. Ah, shoot. Alright, you know what? We actually need 2. Alright, let's see if we can wipe this off or scratch it off or something. Alright, you know what? I'll just flip it over and hope I don't bend the wrong one. The reason why we need 2 instead of so what we had, I'm gonna try and see if this comes off. Nope, it does not want to come off. Wow. I mean, I'm sure I could get it to come off, but it's just really stubborn right now. We want 2 because we don't want this wire to end right here, because then it might cut into this slot. So if we have it overlap the front, right, like that, so that's 2 centimeters here, and then it goes through, and then it comes out the other side 2 centimeters from the neutral point to my finger. That's actually going to be perfect, because then it's overlapped and you don't have to worry about this accidentally, cutting this slot or affecting it in any way. So just good design. You want to think about where it could possibly go wrong and eliminate the possibility for it to go wrong. Alright, so this is going to be interesting. We're going to have multiple marks to recognize which one's the one we want. 0.8, right, and then 2 centimeters here to the end. Right, just did the same exact thing, but now we have a bunch of marks, which might be confusing. I have a second pair of pliers here. This one is by Husky. The one I use for grip is by Craftsman. So let's see here. I'll just hold this. This one, the one by Husky, is nice because this root portion here is 90 degrees. So you can grip your workpiece, and make a very nice 90-degree angle here. Right, that's pretty much perfect. And then you do the same thing for this bend. It's a little bit, it wants to rotate a little bit. I'm trying to make sure that doesn't happen. Because you want it to be in the same plane. You don't want this to bend out of plane. It's probably the hardest part about bending wire, is that you want to make sure the bends are to your specifications, I guess. And I think that's pretty much it. We can cut it actually. Just get a. So this one, the Husky one, doesn't have a cutter section, which is unfortunate, but this one does. The one by Craftsman. So I'm just going to. Oh shoot! All right, this is. It's hard to see where it's gonna cut. You just have to be. Trust your tool. Line up the edge. And you really should be wearing goggles, because in case it, just comes off really hard. You want to protect your eyes. So this is going to be a sharp edge. We don't want that. Let's see if we can do that. Kind of like file it down a little bit. I don't know how else to get rid of this really sharp edge. That's the only downside with cutting, is that you end up with these really sharp edges. This is all we really need. Now we need to puncture a hole in this neutral position. The way we do that, I have a tool here. It's a compass by Stedtler. It's a German company. They make stationery and whatnot. You'll see that there's a gear inside, right? It's very cool. But you use this to draw circles, essentially. This is a very sharp point, because you need to have a center point and then you draw your circle. So I typically use this to puncture my holes. You can also use what's it called? A thumbtack, like a pin or of some sort. I just find this to be a little better because it's sharper, so you actually get a cleaner hole. It's not like a blunt mess. So really all we want to do here is line it up with the neutral point, right, which it is in this case. Right, it's lined up. Right, and then make sure it's 90 degrees, and then you just kind of push it through. And if you do it properly, it'll come out on the other side. Right, you see that? That's kind of where it comes out at the neutral point on the other side. Going straight through like that. And you'll have to puncture it from the other side going back, just to get it to, you want to widen the hole a little bit, not too much, but just enough so that you can slide your pin through. Make sure your finger's not there when it comes out full speed. All right, so this is gonna be a tight fit, so all you have to do is just kind of force it to go through, right, and then rotate it in place, and that's all you really need. And yeah, it should be all set. There you go, you have one side done. And so essentially what this is gonna do is blue is gonna wrap around the steel here, pure stainless steel. It's actually a little bit tight. I thought it I thought it was a little big, but it turns out it's actually a little tight, which is good. We want it to not have any play, right? We don't want the movement to have slack. But this is good. This is good, and we'll have to tape this once we wrap this around and assemble it. And do the same thing for the other side, and then do the same procedure, because while we're at it, might as well, you know. Where's the leftover paper clip here? That's right here. Alright, that's good. Gonna do the same marking, 2 centimeters, followed by point 0.8. Right. That's gonna be 0.7, 0.8 right here, and then shift it over, and then we're gonna get 2 centimeters here. Okay. So you'll see I have my marks made on this piece, right? 2 centimeters here, 0.8, and then between my 2 fingers here, 2 centimeters. So, I'm gonna bend this again. Alright. Very good 90-degree angle. Hold it at the base here. Oops. Make sure it's 90 degrees. Let's bend this same way. Your C-shaped pin, right? This is the part going through the middle, and now make a cut to this thing. Comes off real easy. It's a very sharp edge. Just gotta kind of file it down a little bit. Very noisy, but it's for our own safety. You can also use the edge here. Trim off a little bit. Okay, now it's a little bit more blunt. It's a little bit more usable. Alright, should be good. And we're going to keep this at neutral. And this is important because we want to synchronize where the pins are. So neutral point here, and neutral point right here. So it's literally at the back of the slot. Make sure that this is in place. That's good. Okay. tool here. Just puncture through. Alright, looks like a successful pinhole. A little bit from here. Just place our pin through. One of the reasons why I also use this stainless steel is that it's lower friction, it's a little bit thinner, right? Because there's no coating, and so it fits through the pinholes nicer too, without a ton of resistance. It's another benefit of having different kinds of materials available. And then, you know, the final step here is just to turn it 90 degrees, right? You literally just force it to go through, and then you're all set. Look at that. Got the 2 pins made. For the front, I'm actually thinking probably need to be straight, just like a straight section of wire. So actually we did this for nothing. This is relevant for the back, but for the front we just need a straight pin, because the way the slats interact with the core is slightly different. So let me just, okay, this is gonna be interesting. I want to fix this back out. Okay. I think the way I have it in the M1 was it's just a straight pin, because the interface of the mechanism is it's not the same as the tail. So this is blocked, but if you take a look here, you'll notice there is a straight kind of orange piece right here, and that's literally just a straight pin without any curvature or anything. It's just straight through. And the reason for that is it's a interesting contact joint. It's not like a bearing per se, but essentially what it is this thing literally just contacts this and then pushes it so that it rotates. It's not wrapped around this thing, and that's part of the reason why we need these elastic bands, is that it maintains that element of pretension to keep this from flopping around, because it's not contained within a bearing, right? This literally can move free, and to prevent it from moving, we have this elastic band in place. So this pin is straight. We do want to give enough margin for that, so I'm thinking just this entire section right here should be sufficient. So we're gonna use that. Just have to straighten out the thing a little bit. Just squeezing it all directions to make it straight. Alright, that's as good as we're gonna make it. The surface finish isn't great. It's a little, I guess, dinged up. it's like a tumbled kind of finish. But really, it's like just a lot of compression causing these patterns, but it should be okay. Let's just do a quick measurement of how long this is. This is approximately, should be 1.8-ish. So it's almost 2, which is all right. Let's just bend this out a little bit. Actually, we don't even need the cutter. All I have to do is just bend this back and forth, and it'll break. It's called fatigue, material fatigue. And just slide this pin through. This is gonna be a little tough. There we go. All right, that's the front pin in place. It's literally a pin. The back one is a little bit different, but the front one is definitely just a pin. Straightforward, literally straight pin. So that's that. So the next step here is to get this tail section secured. Or I guess rather than that, I guess what we need is, if we align this here, just take a look, dry fit this mechanism. It's okay, it's currently like that, so it's a little bit long, but we can't rotate it essentially, but we want to make it just enough to wrap around here. So I'm just gonna do that. Just kind of see where it lines up. Probably gonna be alright, so this bottom of the straw is gonna be where this hinge is gonna be. And then this is literally going to come down and be approximately right there. So let me try that again. So you align this with that mark. So there's a mark here for the back where the hinge line is. Hinge line aligned, base aligned. Alright, cool, that seems in place. Alright, I'm just gonna mark the location here of where we need to wrap around. This is probably the range that we need to wrap around, and then just mark the same thing on the other side here. So we'll probably have to bend this outside portion, not the inner portion. The inner portion is where the curve starts. Alright, just cap this marker. It's really stiff. Let's just make sure that it does, in fact, line up. This is approximately 1.8 centimeters. 1.8. It's a little bit shorter. That should be okay. This is gonna be tough. Alright, so we have this. Right, and then I'm just gonna bend this blue notice that it's not in the same plane, which is unfortunate. We can correct that by twisting it a little bit. I'm going to try and get the same bend on the other side here. This is why aligning is important. These paper clips with the coating, they're not uniformly round in shape. So when you squeeze, it wants to rotate out of plane, which is really unfortunate. God damn it. All right. I have to fix this. Now, the problem with paper clips is that you don't get too many tries. You can't correct your mistakes too much, because if you do, you're going to weaken the metal, which is not good. You don't want the part to break. So, alright, so this is approximately how much we need. Right, coming down, I just need to wrap it around a sample paper clip, because we don't want to actually use this. We don't need to entirely uncurl this. We just need a section of it. Right, so it's all good. Then you just kind of put it here. Try and bend it around. It's a tough component to make. That's why mechanisms are hard. They're very finicky, not very straightforward. Okay, that looks okay right now. Gosh, all right. I'm hoping I don't have to do this again, but who knows? We might have to. It would suck big time. Just twisting this out a little bit. Alright, we're gonna cut this. There's too much material in the way. This is kind of hard to cut because it's too much wire here. So we might have to make a cut first, and then a second one, or actually, should be good. All right, no going back. All in. All right, clip that. Make sure, because it's a little bit off. Just want to push this one in a little bit. Ask me it to align a little bit better, but not sure if we have the room to make that adjustment. Squeezing this together a little bit. Right. Okay, that's kind of what the part looks like right now. See, very tight bends. That's why it's a little difficult to get right. Nothing about this thing is easy. If it were easy, I feel like more people would be doing it, but I feel like this is a pretty niche thing to do in the first place, so maybe not, but there we go. See, it just clicked into place. That's wonderful. Gotta live for those moments, you know, when everything just falls into place because you did all the preparation work. Look at that. That's amazing. It just clicks into place and it's all set to go. It just needs a little bit more reinforcement here, so you just need to bend that to close that loop off. Ah, shit. All right, so this one on the right side, starboard side, actually slipped off. Let's get that to wrap. All right. Let me just remove this whole thing in the first place. Okay. Put it in through this and rotate it down. All right. So this is kind of how I did it. So this is, you have your loop here, you have your blue piece right here that you just made. You literally put it in between, right? Put it in between this, right? Slide this, rotate the silver up, right? Keep the silver in place, rotate the blue down. There's a lot of gymnastics here, but and then you just slide it around that. So this side is good. It's just this side, yeah, I'm trying to get it to wrap around. A little tough. Why is it so stubborn? Alright, maybe we get this side down first. I think it's because of slight errors in fit. That's why it's not working too well. Imagine like if this were machine-made parts, it would fit together like a puzzle. But I'm not a machine, I'm a person. So this is the end result. You see that? We just assembled this tail section here. Blue link, right? This is the link that converts linear motion into rotational motion. The tail surface here, we'll have to figure that out, but it should be all set. And then this, all we need to do left, right? It's the same on both sides. We just need to close off this loop right here, so that it doesn't, you know, when you slide back, when you pull back this mechanism, it doesn't just come loose. So we need to remark this neutral point here. Kind of came off. Oh shit. All right, whatever. We know that this is the neutral point. Right, we already put the pins in place, so markings don't really matter too much. All right. God, this marker is so stiff. Okay, so we have it in place. We should probably attach the actual surfaces right now before we get too far ahead of ourselves. So right now we can still remove it. So let's actually remove it first. We know that it's going to fit, It's just we need to attach these actual tail surfaces. Without those, you know, what's really the point of this mechanism, right? So yeah, let's do that. So this is gonna be the right side, and this is gonna be the left side. What we need to do first is make a fold. There's a ruler. Oops, on this side. All right. Good here, and then we need a second ruler. Cool. We have it all. And essentially this is exactly the same as before, right? How to fold precisely along a line. You just put one edge along the line, like that, and just slide the other. And it's a perfect fold. So we have the right side done. Now we just do the left side. Oh, things are getting a little bit more exciting now when it's all coming together, you know? That like one meme with the Disney character. Forgot the name. Oh yeah, it's all coming together. Anyway, just line it up. And then pinch, fold. You don't need it to be super tight crease. Right, so this is gonna come together now, right? This mechanism, we already drew the path on which to attach this. But it's good to dry fit. Let's see how it fits together here. This is the nice thing. We already did all the preparation work. So we already did the measurements, the precise measurements. So now everything is just gonna click together. Just like that. That's beautiful. All right, so we know we can align it with the path and get a very precise result. So we can just do that, tape it in place. All right, this is the moment we've been waiting for. To align it properly. Honestly, this isn't too critical of a part. We can redo this always, but it's just nice to get it on the first go. That wasn't perfect, but that is good enough for our purposes. Just need a little cut here. Okay, so we can fold this down and over. This side is going to be a little interesting because we don't have a lot of room to fold tape over like this, right? You have a lot of tape on each side, or a lot of surface area to secure the tape on each side. But this, we don't really have that, so I'm just gonna grab my scissors, cut this tape in half. Right, and then grab this. We're just going to reinforce it separately here. We're just going to wrap onto the opposite side. And then just rotate that blue part up a little bit. Secure that side on the inside, right? This is important. And then you just do the same thing, and I need something blunt to push that down. Shoot, maybe just a ruler. Maybe. Yeah, all right. Push that side down in, and then the rest here. And you could just use the other piece of tape as well. Get the back side in. This has to be a secure connection, because otherwise your tail is just gonna fall off your actuation mechanism here. That was a good fit. Just pressing it in from the top side so that the bond here is good. And then it's the same procedure. You just fold this over, try and get this little edge here. Right, like that. Then you just kind of fold it over. Do it too hard, because then you might actually rip the tape. And I've said that in my previous streams as well. So, and then this should be all set, and you just close it up, and then you have your tail. We'll do the closing up later. Don't have to do it at this exact moment. Gotta make sure everything's good first, aligned and symmetric. So let's just do the left side now. Same idea. We already have the path lined up. Right. Actually, we can even dry fit it here. See how it looks. Hopefully there aren't any alignment issues. Okay. Looks good. Let's move this over a little bit. There we go. Hinge line right there. All set. Move glue forward. Oh, that's great. So it's a little bit different on that side. Need a little bit more bend in this. Just slightly more. Okay, so it's not perfect, but we need to adjust it so that the final outer mold line is good to go. So the internal structure might not be aligned if we align the outside to spec. Actually, right, so this wouldn't be a problem if everything were machine made, but like I said before, I'm not a machine, so this is going to be interesting. Line the hinge line perfectly there. Okay, we don't want too big of a gap. We want to be close as possible, but also symmetric on both sides. Why is that? I thought it's 90 degrees. Why does it need more maybe it's not 90 degrees. I'm not sure. Just that in a little bit. There you go. Let's see. Okay. It looks fine. Lines up. This all lines up. It's just this wire. It's offset a little bit. Literally everything else is perfect except for this left side. Too much. I'm just making slight adjustments so that the fit is better. If I can fix this. It's a little late to be doing this. Late as in the progress of this piece. I grab this side, bend. Because if you hold the other side and do it, shit, that might have been too much. This is why it's hard. Mechanisms are hard. They don't always fit. Okay, it's a little better. It's not as perfect, but better than before. Back and correct this. Hopefully it's not too weak. There we go. Okay, that's about it. I don't think I can make any more corrections here. If we do, we might end up breaking it, which would be tragic, because then we have to make this whole thing again. That is much better. Also, now we need to correct the front. This is what happens when I don't do things properly. Make tiny mistakes, they compound over time, and you end up having to go back and fix it anyway. Fold this out, hold it here, fold it. Okay. God, alright. Let's get this. is good. Again, this wouldn't be a problem if we did it right the first time. Just we're making some corrections now. Alright, so that's good. Not as sharp as I'd like it to be, but maybe it'll have to do. The part is weak. It's not as strong as it was. The more corrections you make, the weaker it gets. So, take that as you will. Okay. Alright, so this side is good. See how this side lines up now. Okay. That bend is in the correct location. We just need to move this out a little bit. Maybe just a tad bit more. This is why it's not exactly engineering, because it's not a very precise method of manufacturing. A little bit of it is still variable. It's like an art form, right? You have to use your judgment to make these calls. So it is what it is, but I wonder why this doesn't match up. It's a little off. Tolerance issues, yo. Right, this is the leading edge, that's the leading edge. This does not line up. That's why there's a tiny gap. Trim that off. Round this a little bit more. But really, that you can make that correction later. I just need to fix this right now before I forget. Also, if we close it up, we won't be able to fix this. So we literally only can fix it now. It should be good now. Should match. I'm just gonna move that forward a little bit. Okay, so this is what our tail assembly looks like right now. Dry fit this. That's the thing with mechanisms. You just constrain piece by piece, bit by bit. Then eventually you get there and it's like, wow, everything works. But the process going through it is not straightforward. It's often a little bit painful. Ah, god damn it, I moved it. Alright, let's see this. Okay, looks good. Tape here. Get one side, remove the air bubbles, wrap it tightly to the other side. Here. Okay. Once it's secure, then we're all set. I'm just gonna secure that. be careful not to shift it, because that'll misalign everything. You come up with a better way to attach these things, but this is the most direct way, so it's the simplest way to attach a rod to a flat surface. Okay, that looks good. Right now, let's just fix that a little bit. I just grab a piece of tape here to wrap around. Looks good. You could cut it to this size. I just find it easier to apply two separate pieces rather than cut precisely and then deal with that. So a lot of this, is methodology, right? It's not, the design itself is pretty explanatory. It's just a lot of the improvements are made at the manufacturing level, where you just, it's a matter of how much effort you want to put in, right? The more effort you put in, the better the end product, up to a certain point, right? It's the, what's it called? The law of diminishing returns, right? The more time you spend, the better it's going to get, but the less drastic the improvements are going to be. So if you have the patience and you have the time, and sometimes if you have the money, right, you can make a really great end product. It's just, is it worth it to you, right? And that's kind of where you have to strike a balance with yourself, right? That's why, I have a certain manufacturing tolerance, because I am able to say, okay, I'm happy with this, or I could spend more time and be like, I'm not happy with this, and really get it to zero tolerance, which is almost damn near impossible with so many parts, like, in a project like this. But you can, in theory, spend the extra time to measure these pieces of tape, right, the lengths, and then apply it exactly in the right location, but I just don't think that's necessary, because we're going to be flying this thing eventually anyway, right? It's supposed to be a working model. So for me, the balance is where it is, because I think this will create a good enough end product. It'll look nice, it'll move nicely, right? The mechanism is relatively play-free, it doesn't shift too much, and it'll actually fly, right? It's not a work of art, it's meant to be flown. Planes are meant to fly. So I could argue with you on that last point, though, that it's not a work of art. I think in some ways it is. It's just I don't treat it as such, right? Like with everyday things, I intend to use it. I intend to fly it. That's why it exists. If I wanted to make an art model, I would spend a lot more time on the details, on the looks, than what I currently do, which is already a lot of time, but I would spend even more time, essentially, right? Because then the trade-offs are different. If you want to not function per se, but if you want it to just look really good, then it obviously makes more sense to put more time into making it look good. So it's just kind of my reasoning behind, just the thought, the philosophy behind the design, and why I spend the amount of time that I do for these projects. It's just the reasoning behind that. And I think the reasoning is just as important as the execution, right? If you know you're going in a direction that you set up for yourself, then you're all set, right? So here is the tail surface. It is nearly done. I just have to close it off now. It's a tight fit. Might have to adjust it a little bit, but for the most part, very nice. Might have to trim the inner edge a little tiny bit. It's a little tight, not enough gap. But we'd rather have it be tight and then cut out to adjust rather than have a huge gap, because then you can't really fill it in unless you attach more material, which is not great. So this is good. This is good. Made some decent progress today. We're at 96 minutes, so I have approximately 34 minutes left. 34, 33. It's almost 97 minutes. I'll continue this and see how far we can get. I think what we can do now is tape the trailing edge here, or not. We could tape the inner edge first. There's a little bit of thickness to this thing. That's interesting. The cool thing about the F-16 is that the tail surfaces are a little bit anhedral, and we can actually capture that with this design, because you can bend the wire into that shape. So we'll do that, but that's gonna be like one of the last steps. We don't want to do it right now because it's not ready. But I think we're going to tape the inner edge first. That's very important because we don't want stuff to get in, and right now we have the clearance because it's out in the open, so we can just secure it. Just measuring a little bit here, how much tape we need. There we go. So I'm just gonna tape the back here. Okay. Need to remeasure. I think I measured the actual back, not the back, not the front back. There we go. This is the front portion, right? So measure the tape and get it as close as possible. Fold this really tightly. So the surfaces need to be closed before you it's gonna be kind of hard because remember when we determined the clearance here? It's like what, like 0.3-ish? 0.3 centimeters, so 3 mils, or 3 millimeters. It's just not enough clearance to do a really tight fit. But hey, you know what? This is decent. This is all right. Right. So you can now see what I meant. Right. This tapers to an edge. Right. There's a thickness here, and it tapers down to an edge, which is what I designed for in the actual part. If you go back to my other stream last week or 2 weeks ago, you can notice that. Just trim off some of the excess here. We'll deal with that later. Alright, and then we have this other piece of tape. You want to be delicate with this whole thing. It's not just straightforward. Move that air bubble. Fold this, right, keep the tail section here flat. An important bit is to not get any warping. You don't want to warp the surface because then you can't really use it. That's great. Now just trim this edge it together to prevent it from separating, and then just do one. Ah, shit. Alright. One trim operation. You know what? Just I'm gonna use scissors here. I don't want to cut into the cardstock. There we go. Very clean. I'm gonna do the same thing for the other side, and then we're gonna close off the trailing edge here. But let's get the measurement here. Okay, notice that. Right. Very good. Just tape this on there. Wrap it around. Okay. Pinch the inner edge together. And fold it over. It's not quite perfect. Do that again. That's perfect. As good as it can be, probably. Really tight, really sharp edge, inner edge here. You see, there is a thickness here, and then as you go in, it drops off. It's a nice transition to the actual body, to the fuselage. So this can wrap around, but I don't think I will. I think I'm just gonna cut this off. Alright, you know, they say you're not supposed to cut towards yourself, but I say nay. If it's tape, you can clearly cut towards yourself. And control where it's gonna cut. It's just when like whatever you're cutting is really stiff, that's when you don't want to cut towards yourself. That's dangerous because there's a lot of potential energy stored in your arm. So looks good. Now you just gotta close off the trailing edge and then the back there. Oh, I just noticed this now. It's not perfect, but we're not gonna trim this to match it because I think it looks fine. It matches right now. It's just not perfect. But we do need to close off this side. Just grab a piece right here. All right. Same idea. The trailing edge together, getting really tight, wrapping around. Okay, looks good. We'll have to do the final fit alignment when it's on the finished piece. But, right, we used scissors for the other side, so let's do that here. Don't always have to use X-Actos when it's not easy to use. Okay, that's good. That's good. You can see it fits really nicely in the back. Right? Piece by piece. Just takes time and patience. which I realize not everybody has, but it's a good thing to cultivate. It's a good skill. All right, looks pretty decent here. So the tail is nearly done. All right, I just need to tape the trailing edge real quick. Scrap here. All right, so this is how I measure how much tape I need. It's really just by eyeball, by inspection. Right, and you realize I'm not going all the way out. I'm just going to the end of the straight section here. So you have a piece that's tailored exactly for this edge. And try to reduce waste that way. You can definitely go over and then cut down. It's just cleaner to do it this way. No cuts, no anything. Perfect edge. See that? Very sharp trailing edge, which is good. Okay, so now we just need to do this side. For this side, I can put the fillet in there. Just match this edge. Perfect. Just do it like that. Right, pitch together. Make sure it's a sharp trailing edge here. Right. Very nice. You see that? It's a very nice edge. Split right down the middle. Thickness on top and on bottom. That's perfect. Oh, just dropped it. For the outer edge, I'm going to do a quick trim operation to match the contours here. And then we're gonna start to seal this thing up. So there's gonna be a little round area here that we're probably not gonna tape, just because dirt likely won't get in there, and it's just really ugly if you just like tape it, straight up tape it, you know. Because it's hard to tape around a rounded corner here. In fact, you see, this is the problem. Just trim that off. So that wasn't a great fold, but ideally it could have been a little bit tighter. But here we have a. All right, you know what? I think it's okay. It's not great, but it's okay. Just gonna leave that little corner open. There's no good way to tape that and make it look good. So, and it'll likely not crash on this edge. If it crashes, it'll probably be the nose or the main wings. So I'm just gonna get a piece of tape like this. Right. Do the same thing here. Seal that up, pinch it really tightly. That's a good seal. Nice. All right. That's good. Looks good. All right, and the tail is done. It's not exactly perfect, but it's good enough for the mechanism. Just gotta make sure it has enough clearance eventually. Great, so now comes the fun part of really finishing the tail section off, which we already previewed before. Just grab this silver piece, put the blue piece through the silver piece, like that. Put the blue piece around the tube, really try and get it to the bottom here. So this side is the part that's giving me trouble. Wrap that blue around. It's a little bit frustrating, but you know, just gotta deal with it. Okay, wrapped around both sides, and then you just align this forward, just pull on the, oh, that's not good. All right, so the blue accidentally slid into the tube, which is not good. All right, let's fix that. Okay, now it's good. This is why you need to be careful. You don't want to exert too much force and get too ahead of yourself. This is the tail assembly. It is pretty much all set, except it's not. You thought. This blue piece does need to be closed off, so we're gonna do that real quick. Thinking about a way to do this. It's not gonna be great. It's untested, is what I mean. I don't know if it's actually gonna be great, but the idea is you literally, you align it, and then you just grab your pliers, pinch it close. Does that work? Nope, still slides. Damn it. All right. Okay, all right, carefully peel this back, and I hate this. This is like, we're so close, but you just need to spend a little bit more time for this. Exert too much force on the piece. I'm thinking about how to do this. It's really tough to get it around, so maybe removing it is not the best idea. I see no other option. This is really hard to make it while it's on the piece. So we're gonna have to remove this again. I'm so sorry for going back and forth. This is not a very straightforward process. Again, probably not a lot of people will follow this, but I'm just showing my process. I'm gonna remove this, and we're gonna grab this and open it up a little bit. By a little bit, I actually mean a lot of bit. Alright, and we're gonna make the cut. even closer. Alright, wrap this a little bit more. I'll do the same thing on this side. Okay. Now we don't want to cut too close. That would suck, because then we have to unwrap the blue part and go for it again. We want to have enough material. So that we can close off the loop. Okay, that's good. I just need to do the same thing on this side. Okay, let's hope I just didn't make like a dumb mistake. That would suck. That would suck big time. But let's see if I actually made a mistake or not. Alright, you put this through, right? Silver up, wrap this blue around. Oh, nice. Alright. Now I just need this to be a tighter bend. This is perhaps the most difficult part. Alright, we need to pre-bend it a little bit. Hoo boy. This is intense. Alright. This is the moment we've been waiting for. Fits together. That's good. And while it's still there, just need to maintain a little bit of tension on this piece. God damn it. Alright, it keeps on shifting. Alright, okay. You don't want it to go inside the tube, damn it. You see the problem here? The blue is going into the orange, which is not good. Shit. Alright. You know what? Fuck it. We're just gonna go for it. This is very clumsy. Not a very easy thing. It's not like Legos where it just clicks together. Alright, you know what? I think I know the problem. It's pointing in. I need to correct that. Twist it out a little bit. There we go. Should be better. Let's see. better fucking work. Holy shit. You see all the markings are coming off too. It's not a very frictionless process, I guess you could say. All right, have it in place. Oh my god, just fucking go together, damn it. We need a little bit more. See, this is why it's freaking annoying when it's almost there, but it just like doesn't work. I pretty much need to close it up 90% of the way. Let's hope it still fits. That would suck if it didn't. Alright, this is, as you can tell, this is pretty frustrating, but we had so much patience up to this point. We don't want to waste all our work, so let's be careful. That's good. That's good, it wraps around. Now I can finish it off. See that? Sorry if it's not on camera, the earlier bits, but we just closed off one side and apply some tension here. Apply some tension. And we just closed off the other side. Sweet Jesus. All right, we did it. We did it. We closed it off. Nice. So now it's gonna work. Hopefully it's not too tight. Oh my god. Don't tell me it's too tight. Alright, well, it can move forward. I'm not sure why it can't move backwards. Maybe the mechanism is a little bit too tight. Fucking hell. This is why it's not easy. You know, you got like friction and like tolerances, and I'm just mumbling to myself. This is an easy enough fix. It's just a little annoying to do. Just gotta redo this silver piece and then move the blue out a little bit because it's pinching the main shaft a little bit too hard. Damn. Alright. I thought I was done, but I guess not. Let's see. We got 5 minutes left. Let's see. Without playing too much first. Why is it stuck? Oh, it's stuck because of the forward pin. That's why. Right. That was an issue. So I don't want to rip the forward pin slot. But this is the reason why we can't go any back. This is perfectly fine. There is room to go back. I don't think it's friction here that's preventing it from going back. I think, in fact, what's happening is this pin is blocking, right? This slot is like literally limiting the movement of the thing. So yeah, that's why we can't go backwards. So great. So it works. So literally all we need to do now is tape this bit. That's gonna be interesting because I've never done this before, so I don't know if it'll work even. Just grab half half width tape and secure this location right here. Actually, before we do that, pinch it in. Sorry, I'm not getting this on camera. I'm just really focused right now. Can it still move forward? Oh, it's having a little bit of trouble. All right, maybe this isn't a good idea, right? It's not tested. Hell, how did I? Oh, there it is. There it is. My bad. All right. This is not working. I think it's because there's an angle to it. That's why it's not shifting freely. There we go. Okay. Well, in that case, we just hope that this doesn't slide off, I guess. We could trim this. I don't know if it's even possible at this point. It's really close. Trim the silver, I mean, right? This is really, let's see if we can do that. Because my reasoning was this was going to be taped flat to this, but what's happening is there's actually an angle if you force it to come in, right? So if you force it to come in, there's going to be an angle, and if you tape that, it's going to prevent it from going forward. So maybe we just cut it, call it a day. But to do that, we need to get pretty close, which I don't think this tool can do. Yeah, I don't know. I think I'm just gonna leave it. I don't think it'll interfere with movement. It's pretty stuck at this position. It has no reason to want to go down. But literally this is all it does. It's just hanging on for the ride. Okay, maybe it's a good idea to cut it. It's rotating a little bit. But, you know, I'll have to end this today. But in the next stream, I'll definitely fix this issue. I do want to end on time, so. All right, guys, thanks for watching. Talk to you later.